Listen carefully to this. Let's set aside all the politics and media noise for a moment. Let's analyze this from the ground up, from first principles. We have an extraordinary space telescope that pointed its instruments toward a world located 120 light-years away. We're talking about K2-18b, and it detected dimethyl sulfide floating in its atmosphere. Why should we care? Because here on Earth, only living organisms produce this substance. Phytoplankton, those microscopic creatures that inhabit our oceans, are solely responsible for it. There's no known geological process or bizarre chemical reaction that produces it spontaneously. This is a genuine biological signature, and now we're seeing it out there, orbiting another star. The implications are monumental. It represents a paradigm shift in our understanding of the universe. Even if we can't yet travel there, confirm it directly. The analysis reveals something else. Traces of dimethyl disulfide DMDS, another compound of biological origin. In light of this, the silence of space agencies became more unsettling than any official statement. A complete absence of denial. Scientists insisted that the data had been verified. Moreover, these compounds appeared in an atmosphere composed of water vapor, methane, and carbon dioxide, exactly the combination that organic life as we know it requires. Yet no one dared utter the forbidden word: life. Doing so would demolish decades of comfortably maintained paradigms built upon the convenient doubt that we are alone. But now, the universe seems to be responding. K2-18b is not a copy of Earth. It's a transitional world, larger, denser. Its mass is 8.6 times that of Earth, and its radius is 2.6 times greater. It belongs to the Hycean category, a recent theoretical classification describing oceanic worlds covered by hydrogen-rich atmospheres. Its host star is a cool red dwarf emitting dim light, but the planet's orbit passes through the habitable zone, that narrow band where water remains liquid. Imagine a deep global ocean shrouded by a thick atmosphere, where conditions allow complex chemical reactions, the very same reactions that, billions of years ago, gave rise to life on our planet. This isn't baseless speculation. It's a reconstruction based on advanced spectroscopy from the James Webb Space Telescope. The results were so clear, they demanded a new interpretation. Science now faces an unbearable dilemma. Either there's life out there, or our understanding of planetary atmosphere formation is severely limited. Neither option allows us to cling to the comfortable certainty that life is rare and isolated. How can we accept that a planet so different and distant synthesizes exactly the same compounds without the same cause? From Cambridge to Caltech, across leading research centers, the same question arose: are we witnessing a new kind of planetary chemistry or the first confirmed extraterrestrial biosphere? The conclusions converged. The known geochemical catalog offers no explanation for such an abundance of these molecules. The paradigm began to crack. The real breakthrough wasn't scientific, but symbolic. For the first time, the possible confirmation of life beyond Earth did not trigger panic or mass denial. Instead came a reverent, tense, almost spiritual silence. Why do we invest billions in space exploration if, deep down, we're not searching for this very answer? And what do we do now that the answer might already be here? Micro-conflicts began to multiply. Scientists split between camps of caution and enthusiasm. Philosophers debated the meaning of the discovery. Religious communities reacted with a full spectrum of interpretations, from confirmation of divine creation to a threat to spiritual order. Humanity was facing, for the first time, a question impossible to ignore. If you're enjoying this analysis, subscribe to the channel for more content about scientific discoveries that challenge our understanding of the universe. The most unsettling thing isn't the existence of life beyond Earth. It's a reflection it casts. If life exists elsewhere and shares molecules with us, then it's not a rare accident, but a natural consequence of how the cosmos works. The universe stops being an indifferent stage and becomes a fertile, pulsating, perhaps even conscious organism. Here arises a question that begins to tear at our current convictions. Are we ready to accept that we are not the center of universal biology? And more importantly, perhaps we are just a chapter in a much longer book, written in molecules, oceans, and atmospheres. K2-18b is inviting us to an encounter, It emits no flashing lights, no radio waves. It simply exists. And its mere existence challenges us. Because if what we are observing is real, then the universe was inhabited long before we appeared. When the news broke, it spread across phones, forums, and podcasts. For a week, K2-18b trended worldwide. This distant world achieved something no global event had ever accomplished. It forced humanity into a momentary silence, all looking toward the same point. The eternal question, are we alone, was replaced by a far more uncomfortable one. What changes when we're not? The SETI Institute released a formal statement calling for further observations. But behind the scenes, astrobiologists were confronting the very real possibility that life is a common phenomenon. This idea strikes deeper than any alien threat. It challenges a human pride built for centuries upon our supposed exceptionalism. Now, the mere fact of finding a biogenic molecule where it shouldn't exist destroys that sense of security. This isn't merely a scientific shift. It's a civilizational one. The response was planetary. In Kyoto, Buddhist monks held a ceremony of cosmic contemplation, celebrating not extraterrestrials, but a confirmation of a living cosmos. The Vatican declared that extraterrestrial life does not contradict Christian principles and is part of divine creation. Across Europe, educational programs began revisions, incorporating applied exobiology. In France, philosophers and climatologists debated how the discovery of distant biospheres might affect our ecological behavior. The reasoning was simple. If life exists elsewhere, the value of life here increases. The most unpredictable effects appeared in daily life. Teachers began their classes showing images of K2-18b, and students asked deeper questions about their place in the universe. Artists created installations evoking the feeling of being watched by something faceless yet conscious. Internet searches about extraterrestrial life rose by 640%. Leave your thoughts in the comments. Do you think we're ready as a civilization to accept that we're not alone? Culture began to adapt to a new reality in which contact was no longer fiction, but probability. And yet, amid all this, a sense of melancholy grew. If life exists, why does the universe remain silent? The Fermi paradox took on a darker tone. Perhaps the answer is that life exists, but it is microscopic. It doesn't build ships or send signals. It breathes, absorbs light, produces molecules, and probably evolves. The idea of isolation was always our armor, the cosmic alibi that justified arrogance and the destruction of our own planet. But with the shadow of another ecosystem comes the awareness of cosmic responsibility. This silent world shows us what we could lose. If life 120 light years away cannot send messages, we remain the only ones capable of speaking on its behalf, of protecting its story and preserving the fragile thread that connects carbon, time, and consciousness. This changes everything. The reaction within scientific circles was pragmatic. Space agencies redistributed funds. Prioritizing next-generation telescopes like LUVOIR, engineers proposed upgrades to missions specializing in exoplanet atmospheres. It was no longer just about the desire to discover, but about observing with precision, building a cosmic monitoring system not to exploit, but to preserve. Each click, each conversation about K2-18b amplifies the signal, expanding horizons. The idea of life beyond Earth has ceased to be a curiosity. It has become a new global perspective. By understanding this, you're already part of the greatest cultural experiment in human history, recognizing that we are not the end, merely one among countless points. This leads to the deepest question, one that transcends science and touches the very nature of reality. What if the universe itself possesses consciousness? In March 2025, scientists published a detailed analysis of K2-18b's atmosphere. What should have been routine data became a chemical map of a possible biosphere. The light absorption spectrum passing through the planet's atmosphere revealed not only the presence of dimethyl sulfide and methane, but also their seasonal fluctuations. These small yet consistent variations, measured over multiple transits, mirror the oscillations of terrestrial gases linked to seasons and biological activity. With no convincing geological explanation, experts began asking, are we observing an alien respiratory cycle? Attempts to model this behavior through abiotic chemistry failed. None of the 12-plus scenarios could reproduce the observed ratios without assuming absurd physical conditions. Alternative hypotheses, such as cosmic ray interactions with the ocean, would require unprecedented planetary chemistry, something stranger than life itself. This reveals a dilemma that transcends science. Do we seek familiar patterns because we can't accept the unfamiliar? Systems biologist Jacques Darmo suggested that we are not simply observing life, but the emergence of a living pattern, a self-organized system with atmospheric metabolism and cyclical regulation. According to him, K2-18b's atmosphere behaves like a single organism, where the interaction between ocean, light, and chemistry created a cybernetic environment akin to planetary lungs. This provocative hypothesis, reminiscent of James Lovelock's Gaia theory, demands conceptual courage. Yet these are precisely the models now required to explain reality. In the boldest scientific circles, the idea of the analog biosphere is gaining traction. It proposes that planets like K2-18b are not exceptions, but structural repetitions with the laws of chemistry, given liquid water and light, inevitably generate bioactive patterns. Computational simulations confirm this probability. Supercomputers analyzing hundreds of millions of atmospheric combinations for Hycean planets showed that in 19% of cases, profiles similar to K2-18b emerge, and in 3%, the system spontaneously transitions into oscillatory cycles resembling biological activity. These numbers suggest that K2-18b may not be unique, merely the first well-studied example. This cosmic repetition is unsettling because it strikes directly at the idea of human exceptionalism. What does it mean to discover that life might be a universal standard? Does this alter the value of human life and the ethics of space exploration? These questions transcend astrobiology, reaching into bioethics, philosophy, and interplanetary responsibility. Researchers are already revising exoplanet analysis protocols, while AI laboratories train algorithms to detect biological anomalies free from human bias. The goal: to create machines capable of recognizing living patterns, even if we still lack the words to name them. Imagine that by 2030, next-generation telescopes confirm breathing atmospheres on dozens of planets. The conclusion would not simply be there's life, but life is a cosmic vector, a fundamental structure of the universe. The focus would shift from seeking life to learning from it. Yet the most uncomfortable question remains: how do we live in a world where the answer has already been given, and continue to act as if it hasn't? How do we teach science, politics, and ethics knowing that our references are no longer absolute? Meanwhile, K2-18b keeps orbiting its star, possibly breathing, with clouds that change according to cycles we don't yet understand. The most disturbing thing isn't what we see in it, but what it reveals about ourselves. When data points to something too unsettling to fit into our narratives, we often choose to ignore it. That's exactly what began happening with K2-18b. After the initial wave of excitement, the news cycle returned to internal issues, and the planet once again became a technical term in specialized journals. But over the past 2 years, it has continued to emit signals. The expanded observation program showed that the density of water vapor in its atmosphere oscillates synchronously with methane absorption on Earth, a clear sign of interaction between biosphere and climate. Yet in public reports, this information was buried in footnotes under the pretext of insufficient statistical significance. At what point did we stop giving urgency to something that could redefine our species? Don't forget to turn on the notification bell so you don't miss our upcoming videos. We'll continue exploring this and other revolutionary discoveries. In academic circles, the topic continued to be debated. An internal report from an interdisciplinary group at the University of Cambridge, leaked in February 2025, concluded that the probability of a non-biological origin for the K2-18b signals is below 1.7%, a confidence level acceptable in clinical research. Yet these findings were never officially published. Why? Because acknowledging even microscopic extraterrestrial life isn't just a scientific issue. It's about security, religion, and narrative control. Equally revealing was the ESA's silence regarding its joint report with France on thermal anomalies in the planet's atmosphere. The research identified zones of stable, moderate temperature, contradicting standard models and pointing to constant internal heat sources. under oceanic planet conditions. Geochemistry is ruled out, which leaves biology. Yet the official report never used that word once, opting instead for euphemisms like irregular radiative activity. This fear of consequences isn't new. In 2001, after NASA detected possible microfossils in a Martian meteorite, it faced a wave of skepticism that undermined trust in its data. With K2-18b, the same pattern repeats: a manifestation of planetary-scale cognitive bias, an institutionalized blindness that avoids confirming what would demand a civilizational restructuring. The exception was an article by Indian researcher Rajesh Patel, published in May 2025, claiming that K2-18b represents the first self-regulating chemical system beyond Earth, which he called Proto-Gaia, a planetary organism in formation. According to him, the observed molecules are not byproducts of life, but components of a dynamic ecosystem in equilibrium. In other words, the planet is alive, a system that breathes, reacts, and adapts. The scientific community's reaction was cautious, but simulations based on Patel's theory showed that the planet's climate could only remain stable through a carbon restoration process, something that on Earth is carried out by marine life. What if the universe isn't silent, but communicates in molecular language? Will we learn to understand it? The deepest layer of this discussion touches on the ethics of observation. Since the first radioastronomical discoveries, the principle has been to observe without touching. With K2-18b, that principle is being tested. Planetary protection groups now advocate for the creation of cosmic silence zones, where artificial signals will be banned to avoid contaminating emerging biospheres. It's a radical inversion, protecting others from our impact, not out of fear, but from understanding that to observe is already to intervene. History is full of examples where contact with new ecosystems led to collapse. We are now living to the birth of interplanetary ethics, the recognition that the universe is not a barren desert, but a space where life can arise in ways we do not control. The question is no longer, is there life out there? That's becoming evident. The real question is, are we worthy of finding it? K2-18b doesn't shout or send signals. It simply exists orbiting its cold star. Its atmosphere contains compounds that here on Earth mean only one thing: life. For decades, we've waited for contact, imagining machines and voices, but what we found is organized chemistry, a pulsating atmosphere. We now face an uncomfortable truth. The universe may be full of life that doesn't communicate with us simply because it doesn't need to. For the first time, we are not the protagonists of this story. We are observers, and perhaps intruders. The question is no longer are we alone, but what will we do now that we're not? Ignoring this reality is impossible. The data exists. The James Webb Telescope has revealed a world that breathes. This isn't just a scientific discovery. It's a shift in perspective. K2-18b forces us to see ourselves as part of a cosmic network that doesn't revolve around us. History has shown time and again that the greatest danger is not the unknown, but our inability to recognize it. Now the cosmos presents a new kind of presence, life without a face, without a voice, yet with order and perhaps intention. On a personal level, this discovery dismantles the idea of an indifferent universe where life is an accident. What if life is a structural tendency, a process that emerges naturally? This thought doesn't diminish Earth's significance, it elevates it, making every breath part of an ancestral chain that didn't begin here. Scientifically, new observation protocols are being discussed. Even the concept of exobiological conservation. Space is no longer a realm of conquest, but an ethical territory. But the real rupture happens at the civilizational level. If we recognize that life is widespread, all our notions of exceptionalism collapse. The idea of being chosen loses its power, and that terrifies us. Governments don't know how to react. Religions are redefining the boundaries of the sacred. Educators are seeking ways to present this new reality. Scientists, even with data in hand, hesitate because paradigm-breaking truths are rarely accepted without resistance. The risk of ignoring this is to continue behaving like an isolated, short-sighted species, destroying our own planet. But the risk of understanding it demands radical change, humility, disciplined curiosity, and the courage to face a reality that does not revolve around the human being. The question isn't what lives on K2-18b, but what this tells us about the meaning of life here. And it's precisely here that science meets philosophy. The discovery of biosignatures is not a technical victory. It's a call to rethink the structure of reality. We have traveled from floating molecules to the necessity of reconsidering humanity's role. Now that the data exists, ignoring it is no longer innocence. It is complicity with denial. You have heard the whisper of organic molecules in the dark. The question is no longer whether life exists, but what lies behind it. We are speaking of something that transcends science, the possibility that the universe itself is conscious, not as a metaphor, but as a living system. If you've made it this far, you're ready for the next step. This isn't about seeking simple answers. It's about diving into the abyss between what we call reality and what the cosmos is trying to tell us. Share this video with those who still believe the universe is indifferent. Every great transformation begins this way, with a world that demands breath and eyes willing to notice. See you in the next video. Help me reach my first 1,000 subscribers.